Okay, guys, it goes really quickly. And as we talked about last time, it's really important when you're practicing to time yourself because 2 minutes is not a lot of time. But the good news is it's more time than you need if you're skilled at these questions. So this says, which of the following is the unit digit of 7 to the 49th power? You know, it would take you probably 3 months to write this out because you'd make so many mistakes. Obviously, it would not be doable in 2 minutes. So that tells us immediately there's some trick or some pattern involved in a question like this. Now, just to make sure we're all on the same page, you know, what's the unit digit? Well, if you pick some arbitrary number like, I don't know, call it 214, the unit digit is just the ones digit. It's the digit that's in the ones position of the number. And these are kind of interesting entities for standardized tests because they create lots of interesting patterns that students can determine. Okay, so how do we go about solving this? Well, there's an easy way and there's a hard way. We're going to show you the easy way. The easy way is to start looking at what happens when you raise powers of 7 to exponents, right? Because we're looking for the units digit of 7 to the 49th power. Okay, well, what if we raise 7 to the first power? Of course, that's 7, unit digit of 7. If we raise 7 to the second power, that's a 49, unit digit of 9. If we cube 7, that's what, 343, unit digit of 3. If we raise 7 to the 4th power, we get what? Multiply that by 7 again, we get about 2,401. And I'm going to stop right there, guys, because you're going to take my word for it that if we continued to raise 7 to higher and higher powers, what we would see is that the pattern repeats itself on to infinity. What do I mean by that? Well, I mean you will continue to see the units digits following this pattern on into infinity. And that's nice because anything that's a constant is something that we can exploit. Okay, now we talked a little bit about this last time, but here's what you have to realize. What this tells us, and listen really carefully, is any base of 7 that's raised to a multiple of 4, is going to have 1 as its unit digit. Okay, it doesn't matter what the number is. If it's a multiple of 4, if the exponent is a multiple of 4, the unit digit of this number is going to be a 1. Okay? Now, that's important because look at what we're asked for. We're asked for the unit digit of 7 to the 49th power. Well, if we can find the closest multiple of 4 to 49, we know that the unit digit is going to be a 1. Okay, so divisibility rules are very helpful here, but we can quickly determine that 7 raised to the 48th power is the closest multiple of 4 to 49. So what that means, guys, is 7 raised to the 48th power, whatever the number is, some big ugly number, it's going to have a unit digit of 1. Okay, a unit digit of 1. So how does that help us? Well, if you think about it, the pattern goes from a 1 to a 7 because it goes 7, 9, 3, 1, 7, 9, 3, 1, on and on and on. So if 7 to the 48 has a unit digit of 1, well, therefore 7 to the 49 must simply be one more progression in the pattern, and that means we'll have a unit digit of 7. Okay, so the answer here is D. But because students struggle with this so much, I'm going to sort of summarize this one more time. really briefly. What's the unit digit of 7 to the 49th power? It's a big number, but we don't care about the number. All we care is that the unit digits follow a pattern. When you raise 7 to the first power, you get a unit digit of 7. 7 squared, unit digit of 9. 7 cubed, unit digit of 3. 7 to the 4th, unit digit of 1. So what that means is any exponent of 7, right? When 7 is raised to any exponent that's a multiple of 4, what that means is the unit digit is going to be a 1. Okay, so when we ask ourselves what's the unit digit of 7 to the 49th power, our goal is to find the closest multiple of 4, which is 7 to the 48th. We know that has a unit digit of 1. Okay, so then to get 7 to the 49th, we move one more time through the pattern, right? And remember, guys, the pattern is 7, 9, 3, 1. 7, 9, 3, 1. Okay, so if 7 to the 48th is a 1, well, 7 to the 49 is a 7. Okay, sorry to belabor that point, but it's really important for the rest of the lesson that this is at least a relatively stable topic, this idea right here. So what we're going to do is we're going to take this idea and we're going to make it a little bit more challenging. A little more challenging. It's going to get another problem here for us. Okay. Take what you've learned on this problem and let's give this guy a try. A little bit more difficult, but still doable. Let's shoot for about 2 minutes. And guys, yes, if you have a response, as soon as you get an answer, you can actually key it into the chat box for everyone to see. I'll just make the answers public so everyone can see them. All right, guys, that was a little bit longer. That was about 2 minutes and 30 seconds. It still goes by quickly. So it looks like a difficult problem, but we're going to make it really easy. Now, guys, in our book, there's a whole section, a huge section that gives you tables and things to memorize on unit digits. So I'm not going to torture you all here tonight by writing these all out. Some of these patterns you'll take my word for. If you have the course, the rest of the patterns are memorizable in an hour. You can have them at your disposal forever. What am I talking about? Well, when we look at 88 to the 5th power, again, you're never going to be able to muscle this, right? So instead, what you can realize is that it's only the units digit of 8 that matters here, right? So we're multiplying 8 5 times. Well, what happens with 8s, guys, is they always follow the pattern 8, 4, 2, 6, and it repeats 8, 4, 2. Okay, last pattern here, number in the pattern here is a 6. So again, what that means is that all powers of 8 that are multiples of 4 will have a unit digit of 6, right? Okay, so what we do is we find the closest multiple of 4 to 88 to the 5th. And of course, that's 88 to the 4th. Okay, so 88 to the 4th must have a unit digit of 6. And because we're looking for 88 to the 5th, well, guys, that's just one more into the pattern. Okay, so that must have a unit digit of 8. Okay, so what does that tell us? Well, it tells us that when we raise 88 to the 5th power, the unit digit is going to be an 8. Okay, now we can look at 9. So we're asked about 99 to the 6th power. 99 to the 6th power. Okay, 9s have their own patterns. With 9s, all even powers end in a 1, right? So if you raise 9 to an even number, it ends in a 1. Okay, and odds do what? Try it on your paper and see. Yep, ends in a 9, right? Okay, 99 to the 6th is even. So without doing any more work, we can really quickly see that this ends in a 1. Okay, easy, right? Now all we have to do is look at 77 cubed. We already talked about the powers of 7. We know these guys follow a 7, 9, 3, 1 pattern. Okay, 7, 9, 3, 1. So therefore, 77 to the 3rd must have a unit digit of a 3. Okay, so any of these on their own could be a pretty simple question. But now, not only do we have to do that work, now we have to figure out what's the unit digit of the multiplication of all of these guys. But you know what? It's really easy. It's really easy. So we figured out that the 88 to the 5th had a unit digit of 8. We figured out that the 99 to the 6th had a unit digit of 1. And we figured out that the 77 to the 3rd had a unit digit of 3. So all we have to do to get the unit digit of this multiplication is multiply the unit digits, right? So 8 times 1 times 3 is 24, okay? So the unit digit of this entire multiplication is 4. Now, this may seem like a lot of steps, it may seem complex, but I promise you if you practice with this, it's very, very, very simple, and the patterns never change, okay? Okay, as you're writing down those notes, let's get another problem ready. This time we're going to do one that involves addition. This problem here was multiplication. The next problem we're going to do is addition. Okay, looks pretty tricky, but I promise you there's a simple way to get this done. Let's take about 2 minutes and see if we can work this out in our own papers. Okay, guys, let's take a look at this problem. Again, seems tricky. It's not. It's really, really, really easy. Notice here that all of the answer choices unit digits are different. Okay, and that's going to be very helpful for us. So let's look at these numbers. Let's look at 20 squared. Well, the unit digit of 20 squared is 0, since 0 squared is 0. Now remember, I'm ignoring higher digits. I don't care about tens digits. I don't care about hundreds digits. I don't care about thousands digits. All I care about are unit digits, because only unit digits produce other unit digits. Okay? So what's the units digit of 21 squared? Well, since 1 squared is 1, the unit digit of 21 squared must be 1. Okay, what's the unit digit of 22 squared? Well, since 2 squared is 4, the unit digit of 22 squared must be 4. Okay, what's the unit digit of 23 squared? Well, since 3 squared is 9, the unit digit of 23 squared is 9. Notice the 2 in 23 was completely irrelevant here. The 2 in the tens position will never contribute to a unit digit. Only unit digits make other unit digits. Okay? We'll keep adding these guys in series here. 24 squared, well, because 4 squared is 16, right, a unit digit of 6, 24 squared must also have a unit digit of 6. Okay, one more, 25 squared, well, because 5 squared has a unit digit of 5, 25 squared must also have a unit digit of 5. I'm going to say it again. Okay, only because if there's any of you out here who don't get this or don't see this, I want to make sure it comes to light for you during this webinar. The 2 in 25 was totally irrelevant. It will never contribute to the unit digit, right? So when we ask ourselves, what's the unit digit of 25 squared, all we care about is whatever is being squared in the unit digit here, which is a 5. Only unit digits create other unit digits. Okay, so all we have to do here, guys, is now add up these unit digits. So we have what, 10, 14, 16, 20, plus 5 more. So because these numbers sum to 25, and because the unit digit of 25 is a 5, well, we can easily go back up to the answer choices, and we can see that only one of these little buggers has a period of time. Okay, as you're taking some notes down, let's get another problem ready. This time let's try a data sufficiency. Okay guys, let's give this one a whirl. About 2 minutes. Okay, guys, let's take a look at the solution to this problem. So what we're looking for is the units digit of 4 to the n. So we're looking at 4 raised to some power n. Now, as you all know at this point, data sufficiency, it's really important to take away as much information from the STEM, the question, as you can. Now, of course, this one, there's not too much here for us to work with or simplify, but in general, you should really try and simplify STEM material as much as possible. So we're looking for what's the unit digit of 4 to the n. Let's take a look at statement 1. So n is equal to 2x plus 1, where x is a positive integer. So the key, guys, again, the overarching theme is to take stuff that would otherwise be complex and make it meaningful, make it simple. And that may mean different things to different people, right? Simplicity is many times in the eye of the beholder. But when I look at that, I don't really like looking at n is equal to 2x plus 1 because it's pretty esoteric to me. It could mean a lot of things. I'm not a computer processor. I'm not an Excel sheet, so it's not going to immediately come to me unless I put it in terms that work for my brain. Okay? So what is 2x plus 1? Well, hopefully this is something you guys have memorized from the number properties chapter, so it immediately tells you that we're dealing with an odd integer. Okay, this is sort of the algebraic definition of an odd integer. Why? Well, if you multiply something by 2, right, an integer by 2, you're going to get an even number, right, because 2 multiplied by any integer is going to be an even number. And then if you add 1 to that, regardless of what the value of x is, well, you're going to have an odd integer, right? So what this is telling us is that n is an odd number. And this brings up another good point, guys. The GMAT in general is not just throwing random crap out there for you to field. They have a set body of knowledge that gets disguised in many ways, but at the end of the day, the body of knowledge is pretty stable. Does it change year to year, decade to decade? Yeah, as all things. But at the end of the day, for you guys, it's pretty stable, right? So this is just an interesting way of telling us that n is an odd integer, right? Well, why is that important? Well, at this point, we all know that unit digits follow patterns, right? So what if you raise 4 to the first power? Well, you would see that gives us a unit digit of 4. What if you raised 4 to the second power? You would see that that gives us a unit digit of 6. Okay? And guys, take my word for it. If you continue doing this, what you would find is that 4, as you raise it to higher and higher bases, or exponents rather, higher and higher exponents, will always return a 4, 6, 4, 6, 4, 6 pattern on into infinity. Okay? Well, that's very helpful for us because we can exploit this to make this a very simple question. Very, very simple question. Okay, think about what we could do here. And hopefully you're seeing that what we have is really an even, odd pattern, right? Or, excuse me, an odd, even pattern, just the reverse, odd, even, right? So when 4 is raised to some odd exponent, we get a unit digit of 4. And when 4 is raised to some even exponent, we get a unit digit of 6. Okay, now all of a sudden stuff starts coming together. It sort of sparks our memory and we see, okay, well over here they told us that n was odd, right? So all of a sudden, out of what would normally be sort of a chaotic environment, we can see that what doesn't look to be sufficient is actually sufficient. Because if n is an odd integer, we know the unit digit must be a 4. Okay, so we can have our little grid here, A, T, B, C, E. Well, A worked, so you know our answer choices are not going to be B, C, or E, so those guys are gone. Okay, Let's look at statement 2. Statement 2 shows us something pretty similar. Statement 2 says that n is equal to 2k minus 1. Well, and this is something you should remember for the test, it's the same darn thing, right? Think about 2 times some integer k. Well, that's guaranteed to give you an even number, okay? And if you subtract 1 from an even integer, you'll be sure you have an odd integer, regardless of the value of k. Okay, so again, all this is telling us is that n is an odd integer. Okay, and if n is an odd integer, going back to our pattern, we know the unit digit must be a 4. Okay. So I hope that makes some sense to you guys. You know, obviously it's great on a one-on-one to get feedback and answer questions specific to the student, but this was a pretty good basic introduction to unit digits. And at this point, and with the stuff Jeff is about to do with you, which is a little bit more advanced and a little bit more interesting, you can pretty much take this and run with it wherever you find unit digits. Okay, and as Jeff is teaching, if you have any questions, you can chat me. Okay, so what I'm going to do is turn the ball over to Jeff, and he is going to give you some more interesting stuff to torture you with.
All right, thanks, Scott. So Scott brought up a good point here about how, you know, in this question that we just did, notice we didn't know X and we didn't know what K was in order to answer the question, which is interesting because, you know, to the layperson who doesn't understand the GMAT or maybe who hasn't dived in as deep into the GMAT, they may think that immediately the answer here has to be E because you don't X and K. But for all of you here, I'm sure you know at this point that the GMAT by no means is going to give anyone anything on a silver platter. So what I want to do is I want to kind of continue with the types of things that Scott has previously brought up and get into some more challenging types of questions here. So before we get into the above question, and for those who can't read it, because I know sometimes these signs come out a little cloudy, I'll rewrite it. That's 3 to the 16x plus 19, so that's not a division sign. I want to talk about something Scott brought up at the way beginning of the webinar tonight, and that is certain bases, when they have a repeating pattern of 4, obviously they'll repeat every 4 exponents. And I believe at the beginning he used 7, but 3 along with 2 and 8, they repeat every 4 as well. So if we do our basic pattern here, and one of the things as I'm writing this that students always ask, they ask, well, do I need to have these patterns memorized? And, you know, there are a lot of things to memorize on the GMAT. I would personally say that you need to know that 3 is a repeating pattern of 4. Do I think it needs to be memorized? Not necessarily. I think that as long as you can quickly do what I did here by raising this to exponents, you know, that should be enough. And I'm going to do one more row just so I can highlight something. So obviously 3 to the 5th has a units digit of 3, 3 to the 6th units digit of 9, 3 to the 7 is a 7, and 3 to an 8 is a 1. Now, this repeats every 4 exponents. So I want you to keep that in the back of your mind. And I'm going to keep expanding this 4th row here. And as you keep expanding this 4th row, I want everyone to notice that the exponent of 3 to the 12, 3 to the 16, 3 to the 8, 3 to the 4, they're all multiples of 4. And so when you look at problems like this that have an unknown, like 3 to the 16x plus 19, that's kind of a hint of what to look for when you're answering them. Now, I see some of you already answered, but I'm going to let everyone else take a stab at this question, and I can kind of expand on this a bit further once everyone has answered. Okay, so that was actually 2 minutes. As Scott likes to say, that does go by very quickly. So as I was saying earlier at the beginning of this question, this bottom row here is very important. And it's because each exponent is a multiple of 4. And until infinity, 3 raised to a multiple of 4 is always going to have the same units digit. And as you can see, it's a 1, a 1, a 1, and a 1, so on and so forth. So when I attack this question here, the first thing that I like to do actually is use the exponent rule. That's x to the a plus b equals x to the a times x to the b. Why do I do this? I do this so that I can actually attach 2 bases to our exponents here. So I actually have 3 to the 16x times 3 to the 19th power. Now, based off of everything I just showed everyone, knowing that 16 itself is a multiple of 4, and also knowing that x is an integer, means that 16 times x is definitely going to be a multiple of 4. And when you know it's a multiple of 4, you know that that units digit is going to be 1. So we have that one sorted out. And then we're just left with doing the units digit of 3 to the 19. And to get that, we find the closest multiple of 4 to 19. So we can either find the multiple of 4 below it or above it. If we go below it, we would say 3 to the 16. That gives you a 1. 3 to the 17 is going to give you a 3. 3 to the 18 is going to be your 9. And then finally, 3 to the 19 is going to give you your 7. So what we have here is 1 times 7. So the final units digit here is 7. So it's important to understand, everyone, and Scott brought this up previously, that usually when they're giving you something like 3 to the 16x plus 19 and you see not enough information, usually I see no one put that, but they're usually trapping you into thinking that. And worst case scenario, if you're totally unsure, and especially because this is problem solving, heck, plug a number in for x and then just do, let's say x were 1, then you would do 3 to the 16 plus 19. If x were 2, 3 to the 32 plus 19, you'll see that you'll keep getting a units digit of 7. But this is a really great thing and a really impactful part of the test, because if you see this, it's not only a high-level question, but something you can get right very easily. And I want to bring up one more point before I do the next question, and I kind of want to just ask everyone a yes-no question here. If I were to give you, and some of my students here probably already know what I'm about to ask, if I were to give you 3 to the 18x, where x is an integer, would you be able to give me the units digit of 3 to the 18x? And you can put in a yes or no response into the chat box. And I guess the question should be a consistent units digit. We have 4 yeses. Okay, well, funny enough, the answer is actually no. You're not going to get a consistent units digit. And if we go back to our little grid here, notice the only row I highlighted was the 4th row, where we had 3 to the 4, to the 8, to the 12, to the 16, et cetera, to a multiple of 4. Well, notice that 18 is not a multiple of 4. It's a multiple of 2, it's a multiple of 3, it's a multiple of 6. But that doesn't actually help us. The only way this would work is if we had 3 to a multiple of 4 times x. Now, we could also prove this by saying, okay, fine, what if we plug in integers for x and we say, okay, what's 3 to the 18? Well, 3 to the 18 gives you a units digit of 9. Well, what about 3 to the 36, where x would be 2? Well, that's going to give you a units digit of 1. So right away, we see that this is not consistent and we're getting different units digits. So just be advised that when we're talking about having this unknown variable here, when you're talking about repeating patterns of 4, it only works when the coefficient, or in this case, whatever would be in place of the 18, is itself a multiple of 4. And this is something you can take to the bank and use on any of these very, very challenging questions. So I want to shift our focus to a couple of these questions that involve data sufficiency. And, you know, as Scott was saying, these get very challenging. And right now, if you still feel like, you know, it's a little bit foggy, I guarantee you if you jump into our units digit patterns part of our number properties chapter, you can practice a lot of these, and I think you'll feel very good in a hurry. So let's take a stab at this data sufficiency question. As you get your answer, just punch it into the screen, and I'll give you 2 minutes. Okay, so that is 2 minutes right there. Now, the good news is that everyone seems correct who inputted their answer choices. So a couple things I want to talk about even before I get into this problem. Now, clearly, the concept of 7 to the 40A has been gone over a lot by me in the last 5 minutes. So that's great that everyone picked up on that and saw that. And what I feel is, you know, kind of a 700 level Ask Data Sufficiency question that I would be willing to bet that most people who haven't learned about units digits would not really have a clue of what's going on. So one kind of macro idea that I want to throw out to everyone is the idea of what's being tested in data sufficiency in general on this GMAT. And I'm glad no one chose C, but if you ever find yourself in a similar situation on any exam, remember the GMAT is probably never going to give you every piece of information, like in this case, A being 5 and D being 4, and then saying that the answer is C. Because they can't make this test one that someone could guess and do correctly. So clearly, if you know A is 5 and you know D is 4, you have what 7 to the 48 plus D is, and in all likelihood, you would say, well, that's enough. But for all of you here who are savvy enough to not fall for that, you notice right away that the value of A doesn't matter because 40 is a multiple of 4, and that means that 7, if we're following our pattern, 7, 9, 3, 1, we know that 7 to the 4th power, just like 7 to the 40th, just like 7 to the 40 times a, is going to end in a 1. Now, what's interesting here is we threw in a little wrinkle, and this is a very valid wrinkle that the GMAT also will test on, and we can wrap up with a few of these guys, is they're saying what is the remainder when it's divided by 5. Now, for all of you out there, I'm sure you've done your share of remainder questions, and I'm sure that's one of the topics you probably like the least. But the good news is when you're dividing by 5 or 10, which we'll talk about in a second, the remainder is actually equivalent to the units digit. Or excuse me, the remainder is actually equal to the units digit divided by that number, so either divided by 5 or divided by 10. So clearly, by knowing the units digit of 7 to the 40a, we know the remainder when that is divided by 5. And to expand on that a bit, I know everyone's good on this question here, and I'll just write the answer of B so we all have it. To expand on this, I want to take any random numbers. So let's say I'm taking, and we'll talk about division by 10 here, and then division by 5 here, and then we'll do a question on this. So let's say we're taking 17 and we divide that by 10. Well, you'll notice 10 goes into 17, and I'm ignoring the quotient right now, but the remainder here is 7. If we take 27 and divide it by 10, the remainder is 7. If we take 227 divided by 10, the remainder is 7. And if we take A, B, C, 7 and divide it by 10, where those are all digits, the remainder is also 7. So notice the remainder in each one of these cases is matching the units digits. The reality is you could just ask yourself, what is the remainder when you divide 7 by 10? You'll always see the remainder is 7. Now, what if we're dividing by 5? Well, let's say we have 24 and we want to divide that by 5. Well, the remainder here is 4. Now, most importantly, the thing to understand here is that 4 divided by 5 produces a remainder of 4. So if I gave you 444 divided by 5, remainder is still 4. If I gave you 94 divided by 5, the remainder is 4. Now, each time you can hone in on the fact that you really, in all of these cases, in all of these questions, almost could care less about any digit besides the units digit. And that's when you're dividing by 10 and you're dividing by 5. So this is a cool rule that you can kind of take to the bank with you so that when you get to these problems, you're actually looking at them in a sense where you are looking for units digits and you're not thinking that this is a traditional remainder question. So with that said, we can wrap up with a question that's testing division by 10, and then we can call it a night. Okay, so it looks like everyone is pretty much a pro at units digits at the moment. I see a lot of answers of D, and that is correct. So to run through this, for anyone who's stumbling here, again, the process is make sure you have the pattern down. So 3, 9, 7, 1. Again, you'll notice that the closest multiple of 4 to 123 is actually going to be 3 to the 120. We know that's going to produce a units digit of 1. 121 is a units digit of 3. 3 to the 122 is a units digit of 7. And finally, that's a 9. And finally, 3 to the 123 gives us a units digit of 7. As we said before, when we're dividing by 10, we only care about the units digit, so the remainder is 7. So I would say that this was a pretty productive hour. I think we got through a lot of stuff on units digits. You know, the one thing I'll leave you with is that they can test this in really creative ways. So if you ever find yourself on the test starting to do a lot of challenging math, take a look at the answer choices. If you find that the units digits are all different, it may be a shortcut into getting the right problem. So Scott, I don't know if you have any closing thoughts, but this was great, everyone. So thanks again for coming.
Yeah, no, I just maybe leave you a little bit of strategy, some thoughts, some optimism. You know, guys, just remember, everyone sort of comes into the process of studying for the GMAT, and I feel like it first gets slapped in the face. And, you know, we all feel like, you know, what's going on here? But the overarching theme of all these webinars and in your studying as well should always be to find simplicity, right? If you can leave here with one thing that you remember and that you try to employ regularly, is cut through all the crap, cut through all the difficulty, get right to the simplicity, right? If something can't be explained simplicity, change the way you're thinking about it, change the way you're looking at it, look for patterns, look for quadratic equations, look for unit digits. And as this webinar series continues, yeah, we won't be meeting next week just because of the holidays.